Okay, let's talk about July 20th, 1969. It's the day humanity first stepped onto another world. The Apollo 11 moon landing is, without a doubt, one of our greatest achievements. But here's the thing. It's also one of our most persistent controversies. So let's dive in and really try to separate the facts from the fiction in this whole debate.
And Buzz Aldrin, the second man to actually walk on the moon, he totally understood what was at stake. He gave this really powerful warning about how dangerous misinformation can be, especially when it comes to our shared history. His words are a great reminder of why getting the facts straight really matters.
So you have to wonder, where did all this doubt even begin? Well, you got to remember what was going on at the time. We're talking the absolute peak of the Cold War. The space race between the US and the Soviet Union was incredibly intense. Plus, things like the Vietnam War meant that a lot of people were starting to lose trust in the government. It was kind of the perfect storm for skepticism to grow and for these questions to start popping up.
All right, so for a minute, let's put ourselves in the shoes of the doubters. Let's look at the key questions they've been asking for years, the pieces of evidence that, on the surface, seem really compelling and have kept this whole debate alive for decades.
First up are the shadows. The logic is, if the sun is the only light source up there, shouldn't every single shadow be perfectly parallel? But if you look at a lot of the official NASA photos, they seem to point in all sorts of different directions. So naturally, that led people to wonder if it was all just filmed in a studio with a bunch of different lights.
And then there's this picture. This is probably the most famous one. We all know there's no air on the moon, which means no wind. So how in the world is that flag waving? This is the question you hear all the time. And you can see why. It looks like a dead giveaway, right?
Here's another really good one, the sky. With no atmosphere getting in the way, you'd think the sky on the moon would just be blanketed with stars, brighter than you've ever seen. But in every single photo, every piece of footage, the sky is just black, a total void. Did they just forget to add the stars to the backdrop? And finally, let's talk about the landing site. That lunar lander had a seriously powerful engine. You would absolutely expect it to blast a huge crater in the moon dust when it landed, but the photos show the lander just sitting there, on almost perfectly smooth ground, right next to those famous crystal-clear astronaut footprints. It just doesn't seem to add up.
Okay, those are all genuinely fantastic questions. They make you think. But it turns out a little bit of science, a little bit of physics, and some photography 101 give us some really clear and honestly really cool answers. So let's break these mysteries down one by one.
Let's start with that waving flag. The key thing to remember here is the vacuum of space. When the astronauts were twisting that flagpole into the ground, that motion sent ripples through the nylon fabric. Now here on Earth, air resistance would have stopped those ripples almost immediately. But in a vacuum, there's nothing to slow them down, so they just kept on going for a while, making it look like it was waving in a breeze.
Now, what about those weird non-parallel shadows? There are really two things going on. First, the moon's surface isn't a flat stage. It's bumpy, it's uneven, it's got craters and hills, and all of that is going to naturally warp any shadow that falls on it. Second, the astronauts were using wide-angle lenses which create their own kind of perspective distortion. You put those two things together, and you get shadows that look like they're going in different directions, even with just one light source, the sun.
And what's really cool is thinking about why we can even see things inside the shadows. Well, the moon's surface is incredibly reflective, so sunlight was bouncing off the ground, it was bouncing off the shiny lander, and it was even bouncing off the astronauts' bright white spacesuits. All of that created this natural fill light, just like in a photo studio, that lit up details that should have been totally black.
So what about the missing stars? This one is actually all about basic photography. The moon's surface, in direct, unfiltered sunlight, was ridiculously bright. To take a decent picture without it being a completely blown-out white mess, the camera's settings had to have a really fast shutter speed and a tiny aperture. And while that was perfect for capturing the bright landscape and the astronauts, it was nowhere near sensitive enough to pick up the faint light from distant stars.
Here's a simple way to think about it. It's basically like trying to take a picture of the stars from the middle of Times Square at night. The city lights around you are so bright, so overwhelming, that they just wash out the faint light from the stars, making them impossible to see, let alone photograph. Same principle on the moon.
And that missing crater? Once again, the answer is the vacuum of space. Here on Earth, a rocket blast mixes with the air and creates this huge turbulent cloud that throws dust and debris everywhere. But on the moon, with no air to mix with, the engine exhaust just pushed the dust up, and then gravity simply pulled it straight back down, right around the lander.
No big dusty cloud, no giant crater. And you know what? We have super recent proof of this. In 2023, when India's Chandrayaan-3 spacecraft landed on the moon, it waited for several hours after it touched down before it even deployed its rover. And why did it wait? You guessed it, to give all the dust that kicked up in the vacuum time to settle straight back down. The physics just works.
But beyond just debunking the doubts, there is one absolutely incredible piece of physical proof that the astronauts left behind. Evidence that scientists, and really anyone with the right gear, can check for themselves, today, right now.
It turns out that not just one, but 3 different Apollo missions, Apollo 11, 14, and 15, all left behind these special little devices on the surface of the moon. They're called retroreflectors.
So a laser-ranging retroreflector isn't just any old mirror you'd hang on your wall. It's this really clever panel of mirrors that are designed to do one thing perfectly. Any laser beam that hits it gets reflected directly back to the exact spot it came from. No scattering, just a perfect return trip.
And here is the truly brilliant part. For more than 50 years now, observatories on Earth have been conducting this experiment. They fire a powerful laser beam at one of those reflectors on the moon, and a couple of seconds later, they detect the very same photons coming back. And by timing that round trip down to the nanosecond, they can measure the distance to the moon with an accuracy down to a few centimeters. It's amazing!
So this all leads to one final really simple question. If the Apollo missions were all a big hoax, and humans never actually set foot on the moon, then who put the mirrors there?
When you look at all this evidence, from the basic physics to these experiments you can still do today, it really makes you wonder, why does this conspiracy theory still have so much life in it? And that question takes us into the fascinating psychology of why we believe what we believe.
And maybe, just maybe, the simplest answer is this. Sometimes an achievement is so huge, so monumental, like landing on the moon, that it's almost easier for our brains to look for reasons to doubt it than it is to fully wrap our heads around the fact that we as a species actually pulled it off.
And that leaves us with one last big thought to chew on. We are living in an age where we have more access to facts, data, and scientific proof than at any other time in history. So why is it, in this exact environment, that disbelief and conspiracy can sometimes spread even faster than the truth? It's a really important question, and it's one worth thinking about long after you're done watching this.